This is SpaceTime Series 28, Episode 27, for broadcast on the 3rd of March 2025. Coming up on SpaceTime, a bit of good news, with new observations having all but completely ruled out any possibility of Asteroid 2024 YR4 hitting the Earth. A new study looking at what the Martian core could be like. And NASA's latest mission to the surface of the Moon now underway. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
And we start this week's show with a bit of good news, with new observations having now all but ruled out any possibility of Asteroid 2024 YR4 hitting the Earth. The new calculations by a global network of telescopes, including the European Southern Observatory's Very Large Telescope, the VLT, now show the chances of an impact event are just 0.001%. The asteroid's been closely monitored ever since it was first detected back on December the 27th last year, with early calculations of an Earth impact on December the 22nd, 2032, getting as high as 3.1%. The asteroid, which is estimated to be up to 90 metres wide, would have caused a massive kilometre-wide impact crater had it collided with our planet. And when you include the blast wave, that would be big enough to wipe out an entire city. Because of its size and the likelihood of an impact, the asteroid quickly rose to the top of the European Space Agency's risk list, a catalogue of all space rocks with a chance of hitting the Earth. The Very Large Telescope, or VLT, was used to observe 2024 YR4 in mid-January, giving astronomers the crucial data they needed to more precisely calculate its orbit. Combined with data from other observatories, these new more precise measurements improved science's knowledge of the asteroid's orbit, which originally led to an impact probability exceeding 1%, a key threshold to trigger disaster mitigation efforts. More observations were triggered, and the International Asteroid Warning Network issued potential asteroid impact notification. That alerted planetary defense groups, including the Space Missions Planning Advisory Group, about the possibility of an impact. With multiple telescopes around the world now observing the asteroid and astronomers modelling its orbit in ever finer detail, the impact probability quickly rose to 3.1% on February the 18th, the highest impact probability ever recorded for any asteroid more than 30 metres in size. Of course, as we predicted, the rise and fall of the asteroid's impact probability follows an expected and well-understood pattern. You see, to know where an asteroid will be in the future, astronomers need to extrapolate its trajectory from a small bit of the orbit they've already been able to measure, and the amount of orbit they've been able to measure is determined by the amount of time they've had to observe it. See, because of the uncertainties, the orbit of the asteroid is sort of like a beam from a flashlight. It gets broader and broader and fuzzier with distance. But the longer you can observe it, the more detail you can accumulate, and so the better your projections will be. In other words, the beam becomes sharper and narrower. The new VLT observations, together with data from other observatories, have allowed astronomers to constrain the orbit enough to rule out an impact with the Earth in 2032. The asteroid's highly elongated orbit is now moving it further and further away from our part of the solar system. It'll be back in 2028, when astronomers will get another chance to have a close-up inspection, and maybe even launch a mission to study it more closely. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, a new study looks at what the Martian core is likely to be made of, and NASA's latest mission to the surface of the Moon now underway. All that and more still to come on SpaceTime. Data from NASA's Mars InSight lander mission suggests that the red planet has a liquid core similar to the Earth's outer core. But now new research is suggesting that the Martian core may be at least partially solid. Scientists know the Martian core is lower in density than the Earth's core. That suggests that it contains a lot of lighter elements, such as sulfur. So, researchers from the University of Beirut and the European synchrotron subjected a blend of iron and sulfur to extreme conditions resembling the deep interior of Mars. They observed the formation of an iron-sulfur crystal phase under high pressure and temperatures. And that raises the possibility that the red planet has a solid inner core. A report in the journal Nature Communications found solid crystal structures were forming from iron sulfide at temperatures below roughly 1960 Kelvin. That's 1687 degrees Celsius, which is within the estimated temperature range of the Martian core. The authors say that, below this temperature, crystals could form a solid inner core on the red planet, although further measurements would be required to confirm whether or not this is the case. NASA's InSight lander was a robotic mission designed to study the deep interior of Mars. The mission launched on the 5th of May 2018 aboard an Atlas V 401 rocket from the Cape Canaveral Space Force Station in Florida. It successfully landed on the Elysium Planitia of Mars on November the 26th. InSight was active for 4 years and 19 days until the increasing amount of Martian dust covering its solar arrays finally brought the mission to an end with a loss of contact on December the 15th, 2022. During its operational life, InSight returned Marsquake data indicating the red planet had a molten core with a 1,650 to 1,800 kilometre radius, accounting for over half Mars's total radius. However, there was insufficient data to establish whether or not the inner core region was solid. See, many geoscientists have always assumed that an iron-rich heart of Mars would simply be too hot to solidify. That's partly because the Martian core is richer in lighter elements compared to the Earth's. One of those elements is likely to be sulfur, and that's abundant in Martian rocks on the surface, and it's also seen in meteorites and material that coalesce to form Mars. The study's lead author, Lanjie Mann from Germany's Bayerichs Geotechnical Institute, says that since the 1990s, scientists have known that an iron sulfide phase could theoretically crystallize under Martian core conditions. But they didn't have the experimental techniques to identify the structure and stability. But by using diamond anvil cells, Mann and colleagues were able to subject iron sulfide samples to the sorts of pressures estimated to exist at the Martian core. Simultaneously, laser heating was able to establish high temperatures in the sample, and single crystal diffraction revealed the crystal structure density of this novel phase. Complementary experiments then confirmed iron sulfide could crystallize from liquid when temperatures dropped below 1960 Kelvin plus or minus 105 Kelvin, and that falls well within the temperature range of geophysical models for the Martian core. So, if the Martian core is on the cooler side of predictions, then a solid core seems perfectly reasonable. Future experiments could explore more realistic iron-sulfur mixtures incorporating other light elements such as oxygen and hydrogen. And this work could also help solve another puzzle, a suspected molten zone at the base of the Martian mantle. This 150 kilometre thick layer was predicted by 2 independent analyses from InSight seismic data. If further evidence does support a solid Martian core, then it would cast doubt on the existence of this molten zone at the mantle base. Core region would simply be too cold to melt the overlying mantle material. On the flip side, if new evidence does support the existence of a mantle melt zone, then it would spell bad news for the idea of a solid core. The region would simply be too hot. For now, the question remains open. With InSight's seismic mission complete and no follow-up missions planned, the answer may well lie with a deeper analysis of the existing data. This is SpaceTime. Still to come, NASA's latest mission to the surface of the Moon, and later in the science report, archaeologists discover the tomb of an ancient Egyptian pharaoh, the first such discovery since Tutankhamun. All that and more still to come on SpaceTime. NASA's latest commercial Lunar Payload Services Initiative mission is now on its way to the lunar South Pole. The Intuitive Machines IM-2 spacecraft blasted off from Launch Complex 39A at the Kennedy Space Center in Florida aboard a SpaceX Falcon 9 rocket. The mission includes the Intuitive Machines Athena lunar lander and NASA's Lunar Trailblazer orbiter. Lunar Trailblazer separated from Athena 48 minutes after launch in order to undertake its own separate journey to the Moon. See, Trailblazer is on a longer, more circuitous, indirect flight path. It'll use a series of gravity-assist flybys of the Sun, Earth and Moon over several months to gradually line up for a capture into low lunar orbit, eventually flying just 100 kilometres above the lunar surface and undertaking some 12 orbits a day. Its 2-year primary mission will search for and map sites containing lunar surface water. That's expected to be found in so-called cold traps, permanently shadowed regions of polar crater floors, areas where sunlight never reaches. Trailblazer is equipped with a high-resolution volatiles and minerals moon mapper infrared spectrometer and a lunar thermal mapper infrared multispectral imager. Meanwhile, Athena's target is the Mons Mouton Plateau at the moon's south pole. From launch to landing will take about 8 days. The mission will provide one of the first on-site demonstrations of resource use packages to be used on the moon. The equipment includes a drill and mass spectrometer designed to measure volatiles or gases in the lunar soil. Also aboard is a passive laser retroreflector array. It'll bounce laser light back to any orbiting or incoming spacecraft, providing a unique permanent reference point on the lunar surface. The lander is also equipped with a new 4G cellular phone communication system, an experimental hardened computer, and a small mobile drone called Grace that's designed to literally hop across the lunar surface. This technology demonstration package is designed to test equipment and improve science's understanding of the lunar environment in order to help prepare for future Artemis manned missions to the lunar surface, which are all part of NASA's Moon to Mars program. The Intuitive Machines IM-2 mission follows on from last year's unsuccessful IM-1 mission, which wound up undertaking what they call a hard landing on the lunar surface. In other words, it basically hit the ground so hard, it buckled and tipped over on its side, ending the mission early. Mission managers are hoping for this follow-up mission to progress somewhat more smoothly. This report from NASA TV.
There are more than a dozen NASA and commercial instruments headed to the moon, and we're going to walk you through them. Josh, tell us a little bit about your spacecraft.
Including her solar panels, she's just over 14 feet tall. With the landing gear, she's just shy of 15 feet wide. That's about the length of a standard car parking spot. The lunar lander weighs nearly 1,500 pounds and is capable of delivering about 220 pounds of payload to the lunar surface.
Can you walk us through some of those payloads on Athena?
Absolutely. Let's take a look at some commercial ones. We have Lunar Outpost Map Rover. We have Nokia. You have Lone Star Data Holdings Data Center.
All these commercial payloads that you've been pointing out, they're all on the outside of the lander because, as I understand, Athena's fuel tanks are on the inside of the core structure.
You got it right.
Cool.
That's liquid methane and liquid oxygen tanks inside of the lander. What that requires is extremely cold fuel to be loaded inside of the vehicle. That fueling process started about 3 hours before launch, and fueling stops just before liftoff.
There are more than a dozen instruments on board Athena.
And we're going to walk you through them to show you how they'll inform on how astronauts live and work on the lunar surface in the future.
So let's jump right into the NASA technology demonstrations. We have the Prime 1 suite, which stands for Polar Resources Ice Mining Experiment. It consists of 2 instruments, the Trident drill and a mass spectrometer called MSOLO. And joining us now live to discuss these 2 tools is Dr. Jackie Quinn, Prime 1 Project Manager with NASA. The Trident drill, can you walk us through how this works?
It actually was designed and built by Honeybee Robotics. It's a percussive augering drill, and it has the ability to sample down to 1 meter depth, so that's a little over 3 feet. And the way it works is it goes down in about 4-inch sections. It'll go down 4 inches. It'll collect the lunar regolith on the flutes of the drill. It'll bring it to the surface, deposit on the surface, and then it goes down again another 4 inches and deposits. So do that sequentially until it reaches its terminal depth. One of the very cool things about the Trident drill is it has a temperature sensor in the very tip of the drill. So as we're going down, we're going to stop and take temperature measurements at different depths along the way. MSOLO is a commercially available mass spectrometer built by Infocon, which the engineers and scientists here at the Kennedy Space Center have ruggedized for use in the harsh environment of space. So the MSOLO works in tandem with Trident. When Trident brings up the soil and deposits it on the surface, the activity of depositing it gives enough energy that the frozen gas molecules that are residing on the grains of the soil actually sublimate into the vacuum of space. And when that happens, the mass spectrometer, MSOLO, is able to analyze the molecules and tell us which specific gases we're seeing and what quantity is there.
And so, Jackie, real quick, can you give us the big picture? You know, what does the Prime 1 suite contribute to the overall goal of long-term human presence at the moon?
Yeah, so right now, I would say we're fairly tethered to Earth as human explorers, and we want to be able to have a sustained presence on on the moon, on Mars, on any celestial body. And in order to do that, we need to be able to live off the land. So if we look historically at explorers, say Lewis and Clark that went from Missouri to the Pacific, they were able to do it because they lived off the land. They gathered food and vegetables, they hunted, they drank water. Well, we as explorers of space need to be able to live off the land as well. And the way to do that is to be able to get the water if it's there, and be able to harness it for creating fuel and oxygen. And that's what Prime 1 will do, is to give us those first key engineering components that allow us to design future systems.
Now, also aboard Athena is the Laser Retroreflector Array, or LRA. It's a collection of reflectors. You can also think of them as mirrors that are designed to use reflected light from an orbiting spacecraft laser to help locate landers better on the lunar surface.
Tahira, this technology requires no power to work and has been used since the Apollo era.
Josh, one thing that I think is super cool is that it's controlled from your mission control, and it is a super unique setup.
Nova Control, this is the nerve center of our entire program at Intuitive Machines. We have 3 primary flight controller teams working 24/7 to monitor, command, and control our lunar lander during its journey to the moon and Athena's mission on the lunar surface. Here's a closer look at how Athena may accomplish her mission.
Athena's mission may provide the wisdom required to define how will humanity live and work on the moon.
These kind of questions, where we go from being observers of the moon to builders on the moon, this is the first step to begin to answer those kinds of questions.
Her route to unlocking the moon's secrets follows the same path as an old friend.
Odysseus lunar lander separation confirmed.
Small engine firings refine Athena's trajectory before approaching lunar orbit.
We have to do what's called a lunar orbit insertion. It's about a 900 meter per second maneuver. It's a big burn.
In orbit, Athena checks on her payloads, including Lone Star's data center, and manages extreme heat in the light and frigid cold in darkness.
We're just going in orbit, doing the things you do with satellites. This will be very similar to what we do with our orbit and comm relay satellites, starting with IM-3.
A short engine firing sends Athena into a lower orbit to prepare for one final 600-second burn maneuver to the surface.
And it's a nice ride. The engine provides a steady level of thrust that does pick up a little bit as we deplete fuel, but we control it. Once you're there, you want to expand from that landing spot and go and look at different things.
For approximately 10 days, Athena is designed to support NASA's Prime 1 drill suite, deploy a rover, send a rocket-fueled drone into a crater, and connect those spacecraft using Nokia's 4G LTE lunar surface communications system.
In addition to Athena, Intuitive Machines and NASA developed a first-of-its-kind technology called the Micronova Hopper for IM-2. We're joined now by Trent Martin, the Senior Vice President of Space Systems at Intuitive Machines, to talk about the Hopper. Y'all call the Micronova the Grace Hopper.
We do. Naharika Agrawal, our project manager for the Hopper, named it after Grace Hopper, who was a pioneer in software programming.
Hopper had big support from NASA's Space Technology Mission Directorate through what we call a tipping point award. Can you explain why that is? You know, what is it about Grace that has everybody so excited?
Yeah, so we had decided that we were looking for a technology that could be utilized to go to extreme locations on the moon, in particular places that rovers couldn't go. We had settled on the Hopper, and we started working on the Hopper through a partnership with NASA through the tipping point opportunity. We were able to fund that, fly it to the moon, and prove out this technology, prove that we can go down into pits or down into permanently shadowed regions or even into the lava tubes on the moon.
Wow.
And once she's in a pit or a lava tube or a crater, what payloads do you have on board conducting the science that you expect to get back there?
Yeah, so this first mission, we didn't intend to have any payloads on this, but we actually have 3. So we have a camera system so we can look down, see what's underneath. Through a partnership with the German Space Agency, we added a temperature sensor, a pyrometer, onto the foot of the Hopper so that we can sense the temperature down inside of a permanently shadowed region. And then working with a company out of Hungary called Pulley Space, we put a neutron spectrometer on board so we can actually tell if there's water down inside of a PSR.
You talk about Hopper going inside these craters, these lava tubes. Does she have to hop back out to transmit the data, or can she do it from inside there?
Well, We believe that she's going to have to hop back out. However, partnering with Nokia, we've actually put a Nokia antenna on top of Hopper. And based on the analysis that Nokia has done, we believe that we will be able to communicate outside of that PSR that we're flying into just by bouncing the signals off of the walls of the crater. But we'll find out. That's part of the experiment.
How far away is that crater, and how many hops do you think it'll take to get there?
So we're going to take 5 hops once we get to the surface. 1 to get us off of the lander, and then several different hops to prove that we can fly parabolically, we can fly a steady level flight, we can fly down into the PSR, and then wait a period of time and then fly back out of the PSR. We'll be 700 meters away from the lander by the time we're finished.
Josh, if all goes as planned, this would be the second lunar landing for Intuitive Machines. I mean, that has to feel good.
It does. And just last year, we became the first commercial company to land and operate on the surface of the moon, despite a harder than expected landing caused by a laser altimeter mishap.
Now, so what did your team do to assess IM-1 and really make modifications for this second mission with Athena?
Right. After IM-1, the entire team met and reviewed every minute of the mission. What went right, what went wrong, and identified a few improvements for Athena. Namely, we've taken extra steps in testing to ensure Athena's laser altimeter is rock and roll ready to go, Tahira.
And in that report from NASA TV, we heard from NASA's Tahira Allen, Intuitive Machines Communications Manager Josh Marshall, NASA's Prime 1 Project Manager Jackie Quinn, and Intuitive Machines System Manager Trent Martin. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study claims the ocean currents that make up the Atlantic's water circulation system, known as the Atlantic Meridional Overturning Circulation, may be able to withstand future global warming and could even avoid collapse. The Atlantic Meridional Overturning Circulation System is a key ocean current with a major role in regulating temperatures right around the planet. The findings, reported in the journal Nature, used 34 models from the IPCC to assess the Atlantic Meridional Overturning Circulation's response to extreme changes in greenhouse gas concentrations and North Atlantic freshwater levels. Under these conditions, the authors found the current to be resilient to climate change and did not collapse. The findings indicate that although it's likely the circulation will weaken under global warming scenarios, other ocean processes could end up preventing its collapse. Scientists have found evidence for what's thought to be the earliest known community of humans living in an African rainforest. The researchers found signs of human occupation, including stone tools, at a site in modern-day Western Africa. A report in the journal Nature claims the site dates back some 150,000 years. That's long before any other known rainforest-dwelling humans around the world. This could mean that the wet tropical forests of Africa during early hominid migration were far more habitable than previously thought. Archaeologists have uncovered the tomb of an ancient Egyptian pharaoh, the first since the discovery of Tutankhamun back in 1922. The remarkable discovery of the tomb of Thutmose II, the last missing royal tomb of the 18th dynasty, was found in the western valleys of Egypt's Theban necropolis, 3 kilometres west of the Valley of the Kings at Luxor. However, unlike Tutankhamun's pristine tomb, Thutmose II's resting place was in poor condition due to flooding shortly after the pharaoh's death. Archaeological evidence suggests the contents were moved to a second tomb due to that flooding. The burial chamber featured a wide staircase and large doorway, indicating that it was the tomb of a pharaoh, and it was decorated with scenes from a religious text reserved for the kings. Thutmose II died 3,500 years ago. He's believed to have ruled from about 1483 to 1479 BCE, and he fathered just one child, Thutmose III. Among the objects recovered so far are fragments of alabaster jars used to store perfumes, oils and ointments. They were inscribed with the pharaoh's name and inscriptions bearing the name of his wife, Queen Hatshepsut, who wound up becoming one of Egypt's few female pharaohs. The tomb escaped discovery until now because it was expected to be at the other end of the mountain, closer to the Valley of the Kings. The History Channel's Secret of Skinwalker Ranch is an alleged reality series following a team of paranormal investigators, anthropologists, cryptozoologists and others who are exploring the mysterious paranormal secrets of a 500-acre Utah ranch. The series' heroes investigate everything from monsters to cattle mutilations, UFO sightings, and of course the famous Navajo Skinwalker legend for which the ranch has been named. And like so many shows along a similar vein, there's very little scientific evidence to support any of the fantastic claims the program makes. Even famed ufologists such as Barry Greenwood have expressed their doubts. Tim Mendham from Australian Skeptics says, while there's little to support the supernatural claims made in the show, it is great entertainment, as long as you don't take it too seriously.
Skinwalker Ranch is an area that supposedly had a few UFO sightings and that sort of thing on it, and suddenly becomes the centre of all these weird activities, from UFOs to aliens to monsters to all sorts of psychic and paranormal phenomena, all in this one place. And it was taken over by a fellow in the mid-2000s who has obviously promoted this a lot. There's TV shows all over the place promoting the Skinwalker Ranch, and it's equally been debunked. There's a lot of people who have debunked it, and getting into the Skinwalker Ranch is not easy because they tend to select who goes in there to do their research. But there's all sorts of people, I think some American politicians have been there, one even suggesting that he took a monster, unbeknownst to him, back to Washington or something, that it was sort of embedded in his body or something, followed him, something like that. And there's a lot of people out there who will believe anything. The people who go to Skinwalker Ranch tend to be people who want to be convinced or already are convinced anyway. It's a self-selecting evidence. People say all these things are out there. There's things in the sky, there's things on the ground, there's all sorts of phenomena. It's 500 acres of a hell of a lot of UFOs and weird animals and strange things going on. No serious person takes it seriously. It's a nice publicity thing. It sells TV shows and people like weird TV shows. Some people suggesting that, it's just for entertainment anyway. One researcher, a skeptical researcher, who suggests that it's valuable as entertainment. I'm not quite sure what that means.
Next thing you'll be telling me the X-Files wasn't a documentary series.
I think Skinwalker Ranch, I don't know if it actually featured in the X-Files. It should have done. It's a funny place. And if people say it's entertainment, so big deal. If people start taking it seriously and it endorses their beliefs generally and they start acting upon those beliefs, then it's not just a simple entertainment. It becomes a problem. And this is like a lot of these things. It might be a small problem. It could end up being a big problem depending on the individual who believes it. If you're a politician and you believe that you've taken a monster or a ghost or something back to Washington with you, I would suggest that starts to be a problem.
And that's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.